This is 11.2, proving figures are similar using transformations. So just as a review what similarity is, remember things are similar if and only if things can be mapped to each other through similarity transformations. And these transformations are rigid motions, reflections, translations, and rotations, as well as the new one are dilations. Is a general rule of thumb, similarities preserve shape but do not necessarily preserve size. Okay, so what type of transformation is this? We can look at it. It's a what?
Reflection.
Look at it again carefully. It's a
But
it's not a reflection.
Rotation.
Rotation, good job.
Okay.
It's 180 degrees around the origin. What about this one?
Reflection.
What about that one?
Enlargement.
Yeah, we're going to call it a dilation.
Dilation.
Yeah, because it's dilating. Kind of like your eyeballs, you know how they dilate. Okay. So it says, if two figures are similar, can you conclude that corresponding angles are congruent? What do we think? Yes or no?
Similar.
Are corresponding angles congruent? Yes or no? Make a stand.
I don't think you can conclude that. I think you need more information.
So if things are similar, that means that they're the same shape, right? So if two things are the exact same shape, doink, 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 it doesn't matter how big they are, that the angles here would be the same. So the angles are congruent even though the sides aren't congruent. Okay. Just a reminder, we can use our little cheat sheet here for coordinate notation. For example, xy becomes xy, but then if we have some kind of scale factor for a dilation, we can simply multiply that by both x and y. Sorry. Don't know why it does it. So for example, this triangle here, one way we can do that is we can look at the coordinates. So this coordinate here is at 0, 1. This coordinate here is at 0, 3. Therefore, we can figure out that our scale factor is going to be 3, right? Because we start with the pre-image here. Our image is 3 times larger, essentially, at least around the origin. We can double check with these coordinates. Is that coordinate, does it become 3 times larger? Yes. Does this one become 3 times larger? Yes. So just by writing down these coordinates, it should become pretty obvious that our scale factor here is 3. Okay, what about this guy? What's our scale factor? Well, we can again write down these values. I'll just plug them in. So then what's our scale factor? And another way to do this is we don't need to go coordinate by coordinate. We can just look at the sides too, right? What is the length of this side? It's 2. 2. What is the length of this side? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. What is this? Wow, I'm smart. That's 2. This one's 2 here, right? The length of this one, this is 1, 2, 3, 4. So is this a dilation?
No.
No, good job. Because
it's not a straight doubling.
Exactly. So it doubles here, right? If we just look at this side, the scale factor would be 2. If we looked at this side, 2 is not the scale factor, it's some fraction. So therefore, we can conclude that the two figures are not similar. Okay, see if you can do 4 and 5. Pause right there. Ooh, it's a heretical cup. It's my North Pole cup. Okay, so Number 4, no. And number 5, yes. Okay, and then just like we had sequence of transformations before, we can plug in dilations into our sequence of transformations. I'm just going to kind of skip the details on that, but it's very similar to our other ones. We'll do an example here. For an example, how do we map JKL onto triangle PQR? Well, we're going to have to flip it or rotate it or what?
But how would you map J.K. Rowling?
JKL, not JKR. Don't be a nerd.
Math.
Okay, so we're going to reflect it across this x-axis initially. So that'll plop it down here. So we'll get something like this. And then we're going to rotate it or dilate it and then rotate it either way. But we can rotate it around and we end up with something like this. And then we can do our dilation, or we could do our dilation and then our rotation. Either way. The book has dilation first and then a rotation, but again, the order here isn't super important as long as it ends up in the right spot. All right, see if you can do number 8. Pause here.
It is good to be king.
So we have a reflection and a dilation. Again, we could switch up the order here and do the dilation first and then the reflection. That's totally fine as well. Okay, last little bit of information is just the fact that all circles are similar. So it's just a fact, it may come up, but note here that no matter what the size, right, this circle is the same shape as this circle because they're circles. They're all perfectly similar to each other. Okay, that's it. That's all I got.